Hello, everyone.
Hello, hello all. Good evening. Hi Vivek. Good evening.
Hi, Namtan. Good evening. How are you doing?
Yeah, I'm doing good. Thank you. How about you?
Yeah, great here.
Okay, great to host you here. Looking forward. I guess we can start. Hello all. Good evening. Welcome to Azure Developer Community Tamil Nadu. This is our third or fourth online event, and I'm very excited because we are going to cover 5 hour session on Azure ML. So this session will help you to start your ML journey. And I want to emphasize about our community. So we have reached 2,000 members in Meetup. Probably we started 2021, I guess. We started with some different 100 cities, and we are the one who reach 200 members within some time, and we are very excited about it. And thank you all for supporting us our journey. Wait, next slide. Yep. So what we do, in Tamil Nadu, we are running this Azure developer community among different cities, and it is completely for the technology enthusiasts and open-minded people. So I met Vivek in this community, and we started learning, and also we sharing knowledge with the community. Our mission is to provide a space or provide a some platform to share their knowledge where you can come and upskill yourself, and you can network with others. So this is the best place to learn Azure technologies and data science and machine learning wise. And always we are getting supportive people from different companies or different colleges, different regions. So in that way you can get a right mindset people to grow together. Wait, next. Yeah. So in terms of community, what we do, so mostly we conduct meetups, and currently we are planning offline events monthly once. So mostly it will be on third Saturday, and every month we are conducting offline meetups, and also we are having the online sessions. So and also we are creating a platform to network with the different experienced people. Probably if you are a college passed out, or if you are working in some company and you want to start your Azure journey, so this would be the right place. We have planned some certification jams as well. If you want to start A 900 or AZ 900, we will be having a jams in the upcoming months. And also we have giving talks in some corporates or colleges. We are happy to do. And also if you want to speak in our community, please reach us. I'll be posting one Google form. So if you have any call for papers, you can post it here. We can evaluate it, and we will be hosting you in our meetup. And also we have some fun contest. So in our today session also we have a quiz, so you can participate in it. And coming back to our session, Vivek Raja is going to give a session today, and Vivek Raja is a VP of product in NexStem, and good friend of mine.
You go
Probably
to
I'll hand it
my.
over to Vivek
Okay.
to
I
give
think
a
I missed my.
detailed. Yeah, go ahead, Vivek Raja. Floor is yours. Thank you.
Yeah, thank you. Thank you. So, Burning Brains, yeah, it's going to start right now. So, thanks for your enthusiasm. We have more than 50 to 60 plus viewers in Steam today. So if you're not joined our community, so if you heard it today for the first time, just scan this QR and hop in. So as Navneethan explained, we have a lot of initiatives running ahead here. So today is about, we have 2 days of sessions of boot camp. So we are going to take everything slowly. We are going to learn something in detail. Um, and this is going to be a boot camp for ones who are not experienced also. So even if you have no make a big out of that. So what do we do here? So what is the outcome that you can get out of that? So we have digital badges. We have a lot of contests. I'll explain you as it goes. So before we jump into the session, let's set some ground rules, and also we'll get to know what we are actually going to try to learn for the next 2 days. Don't worry, not going to be a complete 3 hour sessions. I'll try to wrap it up in sort of a before itself. But of course, today's day is going to be fun, filled with events, quiz, and a lot of contests. So by contest, what I mean, you have a lot of plenty of opportunities to compete and win as well. So what you can get out of this bootcamp? Um, so for this bootcamp, we have planned a lot of, we have carefully curated how we wanted to run this bootcamp. So let me go through the outcomes. So first of all, in Azure developer community, Tamil Nadu, what we strongly believe is that uh, we don't want it to make it as a cost related stuff. So it's, for example, if it's an in-person event, there is some cost for running an event. But when it comes to virtual, we will try to keep it as free as possible because we strongly believe in the fact that knowledge is free. It's already available on the internet. We are just mediators who present it to you to help you to learn much more better. So all the code samples, whatever presentation deck that we see today will be available with no restriction of usage for that. So it will be uploaded to GitHub. So since it's uploaded to GitHub and I'm making it available for everyone to use it, one small request that I put out to everyone is that please do star and fork so that we know that it's a piece of work from the original artist. And of course, I want you to go and renovate and work on the code and make it much more better. So I'll be uploading that to GitHub and I'll share the details where you need to find those presentation deck. It will be shared at the end of the bootcamp. And something which we have started from today for this from this bootcamp is that a digital badge for all the contests. What we feel is that certificates are fine, but if you wanted to represent or you wanted to showcase that you have participated in such a organized boot camp for machine learning and you have put some efforts to participate in contests, win it, we taken it's our responsibility to make sure that we give the recognition to you. So that's what we have brought up today, a digital badge platform, so that you can actually get the digital badges based on how you win, and you can put that in your LinkedIn and resume, and you can share across. So it works exactly like a verified digital badge, like what you get in Credly and everything. And today, also for this bootcamp, we are planned for a capstone project. So it's an optional one. So based on the learnings of the next 2 days, if you wanted to take it much more further and wanted to give a hands-on on a complete project, we'll give you the task how we wanted to do it. And if you complete the task, the project, and submit back to us, you'll get a recognition for that. So the Capstone project is optional, and one of the main outcome is for us to learn today. So we are all here to learn. If there are some mistakes in today's presentation, please point it out because that's how we learn each other and make sure that we share the right information. And keep questioning. So if you have any doubts, keep dropping that in chat, and we'll take it from time to time. And the best part of the today's bootcamp is that we don't have any machine learning experience. It's so keep it so be open-minded. It's not necessary you have to sit with the laptop right now and code along with me. We're not going to do that. Sit and listen. Just experience how the flow and everything works. Try to relate your experience with the industry application so that you'll get some idea about how it's really done in the real world. So with that being, I guess those are the outcomes that we have planned to give you. And digital batches. I guess I'm getting a couple of questions on the digital batches even before the event started. So I'll just hop on to see what all is there and what all contests are there for you to win today. So scan right now, and we'll take you to our GitHub repo. So it's a 2 days bootcamp. It has all the information and links that you want to do it. So if you're not a member of our community, please do sign up with this link. Today's live stream is here and the recording will be available in the same link. And we have digital batches. So you could win our digital batches. We'll be adding more batches as it goes. So you could be a bootcamp participant, and you can be a winner of a quiz contest. You can also be a winner of social media contest, and also Capstone champion. And there is one more surprise along with that. So I guess I'm getting a question from Suman. How many days will be provided to complete the Capstone project? So yeah, we will come up with those Capstone project details after the event. So what you could do is we will give you a comfortable time for you to learn, get back with us. We'll have doubt clearing session so that you could complete the Capstone project in a well-mannered way. It's not about the contest; it's about learning. And we have our LinkedIn and Twitter links, so do follow us. So it's a brand new profile, so I would request you all to just go and hit a follow and give a connection request if you have time. And this is my account, my LinkedIn and Twitter. So I respond to almost all the DMs that comes to me. So feel free to reach out if you want to talk anything about tech. And next comes the badges. How you can actually win the. Can you share the GitHub link? Yes, I'm sharing it across. Yeah, it's not necessary for you to join GitHub. So just a showcase page. That's it. I'm quite curious on the Burning Brain's real name because he asks the good questions out here. So again, the contest number one, how you can secure your participation badge. We have a link of today's attendance. You can find it in the GitHub repo. I'll also copy paste at the end of the session. Attendees, please do fill it. It will be based on the participation on 2 days, according to which we'll give you the participation badge. Make sure that you use the same email address for day one and day two, so that we could make sure that you are the same person over here. And we have a social media contest today. So what you have to do is for a social media contest to win a badge, go and go and follow our social media handles. That's the first requirement. Second, try to post as much as you can. Try to make a valuable post about what's happening in the bootcamp so that people will get to know, and you also share that with your social media. And do tag us in the respective social media. So do follow us in the LinkedIn and Twitter, and also just tag us so that we will be only able to track you if you tag us. How we are going to award those people? So top two winners from each social media, LinkedIn and Twitter, for every single day. So for day one as well as day two, we will find the top two and we will be able to give. So based on the number of posts you have and the number of likes as well as shares. So if it's LinkedIn, it's likes and shares. If it's Twitter, it's like and retweets. Okay. So based on that, the cumulative count of it, we will take day wise and we'll give you top two prices for each social media every day. You don't need to submit anything for social media for proof because we will be able to track you based on the tag that you make. So make sure that you tag us right. Go and follow us in this social media and tag us right. I'll paste those links as well, so it's easy for you. This is the GitHub profile. So Vivek0712 / Azure ML Bootcamp. And the third one, which is the surprise, which I was telling you about. I think I'll move my this one, I guess it's hiding. Yeah, the best knowledge sharer batch. So as a community, we strongly believe in three things. One is learning, and another second is sharing, and third one is networking. So social media takes care of your networking part. Your participation ensures your learning here. What about sharing? So do follow the person who going to win the knowledge sharer batch is that do follow our bootcamp session. Take notes of it. So either take notes on your handwritten notes, take a photograph and upload it in your GitHub profile, or do it in any blogging media or any social media if that's the case. And do tag us that you're sharing the notes. The LinkedIn link is broken. Okay, okay. Okay, I'll share it one by one. This is the LinkedIn. I think Ahmed, thanks for pointing out. Can you just verify if you could click that LinkedIn profile link? Just one. And this is our Twitter. I guess so. This should work from what I'm seeing. So social media contest is on right away. Do post about this. And if you are willing to take the notes, do take it in any form. If it's written or you're going to type it, it's fine. Put it any open platform, be it GitHub or blogging profiles, which is best recommended. And then if you want, you can put it in your social medias as well. And do tag us. And that's the only way we will be able to track you. Okay, so share your knowledge on the 2 days of bootcamp. The person we will actually have a day-wise winner. So if you take good notes for today, and we'll be able to share. And we are not going to reveal the number of batches we are going to give for this. So I'm going to keep it secret as of now. So whoever feels to take notes, do it. And we are going to have a surprise quiz contest sometime during the session. So listen to it. It's going to be very easy. So it's going to be an online quiz. So you just have to take a mobile and play with it. And Capstone. I think there was one more question about Capstone. So it will be announced tomorrow. Do join us back tomorrow to reveal all the details. Or you can just check back in our GitHub profile and all the links and details will be here. And for those who have to go and learn again, so we have presentation deck, your recordings, as well as we are going to reveal something called Microsoft Learn collection. So for those who haven't know about it, it's Microsoft Learn is it's actually from Microsoft, which deals with a lot of technicalities and some pathways for you to learn something. We'll talk about it quite detailed in tomorrow, and we'll also explain you what's the process for you to become a champion of that. So keep in mind, guys, we have participation batch, we have social media batch, and we have for knowledge sharers who is going to take notes, and a quiz is also going to come up. With that being said, I'll go back. I guess everyone is now set. You have your GitHub and your profiles and links everywhere available. So I'm going to proceed with today's agenda. So burning brains, I guess now I'm going to, I guess now I'm capturing your attention that we are jumping into our session right away. So what's going to be today's agenda? We are going to split the complete syllabus or the curriculum of this bootcamp into 2 days. So we are going to just see only three topics, four topics. Okay. And yeah. And Chokalingam, yes, Rajendran, yes, the recording will be available in the same link where you're watching this video. But do continually keep watching right now. So if you have any doubts, you can just post and I'll be able to clear you directly. So, but if you don't have the right time, you can always come back and check. But you will miss the lot of content that is going on right now. So we are going to see 4 sections today. For those who are very new to machine learning, there is no point in jumping about learning about hosting a machine learning service in cloud unless we know what is machine learning. So for everyone who is going to who's new here or who doesn't know about machine learning, I'm going to give you a very brief explanation of what is machine learning so that you will be on the same page of others when we go on with the discussions. Second section is about Azure Machine Learning Service. I'm going to take you to Azure portal and walk you through what all services are there. Then we'll jump into Azure Machine Learning Service and then see what do they really have. Okay. We need to mark the attendance at the end. Feel free to mark your attendance right now, but don't have the college tendency that you can just mark your attendance and jump off. Okay. So it's your wish to stay towards the end of the session if you want to learn. And of course, attendance is just for you to showcase. So I would recommend you to fill at the end of the session. That will give you the personal satisfaction and concerns to that you have attended today's event. But feel free to do so. And yeah, Lucifer, I guess that's a person who was behind Burning Brains. So hi. And the third one, let's keep it much more easy. So I don't want to be one-on-one discussions like this. So if you have any chats, I will try to take it up then and there. So we'll have an interactive session as we go. I don't want to bore you like a professor or a trainer. So let's keep it in the different fun way. Then the third one is going to be a very small section on how you can access data in Azure ML and what are the different ways to do it. And we'll also have a training how we need to train your machine learning models in Azure using scripts. We are going to stop on that actually. Okay, feedback. Okay. I'll just rectify it. So just stay on for. Don't fill the form right now. So maybe I'll amend it as we go. Just fill that as of now. Just choose the option one as of now. It shouldn't be a bigger deal. I'll right away change it if that possible, so that it does not make any feedback for option one. Sorry. So what you do, I'll recommend have a feedback. So I'll change that as a paragraph. So feel free to. Oh, I already got 18 responses for attendance. Good that. Fine. And hope so that 18 people stay together at the end of the session. Right. So Abu, yep, I guess just refresh your form. I guess that now it shows a paragraph for you to fill the feedback. Thanks for it. Uh, uh, what is it? Lucifer. So I guess just go back to our GitHub profile. You'll have links for everything. I'm pasting it again, or I'm showcasing that in the screen, as well as I'm bringing up it here. I'm repasting the here. So yeah, just go to this GitHub profile. You have all the links for today. So feel free to just ping it. If you have any uh, feedback or something, just bring it up right away so we can do it. And yeah, so join us. All the bootcamp and details are available in our GitHub profile, or just scan it right away. Lucifer, if you want, just take a mobile and scan it. So we have all the details over here. Let's go to section one. So how many of you here are very new to machine learning that who says that I have heard about the word machine learning, but I really don't know what that means? How many of you here like that? Just drop that info in chat so that we could have more discussions around it if we have more beginners. How many of you are very new to machine learning that I'm learning it for the first time? No matter how much times I have taken what is machine learning, every single time I get some innovative questions about what is machine learning that makes me think that I want to go and relearn from the basics of machine learning. Oh, awesome. So there are a lot of people who are here, so very new to it. I'm from cloud background, but no expo in ML. So I guess Shanmuga Kumar, I guess today is going to be a very perfect session for you because this is going to be a right domain switch for you to learn. Okay, you have Ahmed says that I have experience with ML, but not with Azure ML. Good. I guess then you can easily pick it up. You could relate to it and learn. Lot of people are not familiar with machine learning, so we'll start with basics. And there are few people who have done some machine learning as Jupyter notebooks, which just sits in your desktop system. But have you ever pushed your machine learning models to production? If not, today is the day you're going to, at the end of this 2 days bootcamp, that's where you're going to make your models up and available in cloud for anyone to consume. So I can guarantee you that. So let's start to, I have AWS knowledge, but not in ML. I guess you can easily relate to what's happening over here. There won't be much difference. So the reason is that I also do work in AWS from time to time. So I can see it's just two parallel stuff. You can correlate and learn. Okay, Karthik. So probably Karthik is going to be my moderator probably because he has an experience in Azure Cloud and DevOps and MLOps. So Karthik, feel free that if I go wrong anywhere, feel free to correct me if that's the case. Experience. Oh, awesome. So I got a lot of comments about how people experienced yours. So thank you. Let's move on to the first slide of today. If that's it. What is machine learning? So fundamentally, what Wikipedia says or what my Microsoft document says is that it's a process of using mathematical models of data to help a computer learn without direct instruction. So yeah, let's imagine. I'm going to give you a scenario: is that your dad tells you to go and go and switch on the bike or go and start the bike. Okay, that's an instruction your dad has given you. Now let's assume that you and your dad are sitting inside your home and your bike is obviously outside, correct? So what do? You go and search for your bike key. You go and put on your slippers or your sandals or shoes. You step out of the home. You go to the place where your bike is. You put the key in your key holder. You turn on the ignition and then you kickstart it. That's how you start the bike. But did you really get all those information that you need to do it? So there is one actually. What it really reminds me of people who are Tamil here or who watches Tamil cinema. So there is to be one comedy scene from Singham movie, right? So where the Radha Ravi used to tell Vivek, ask about some details about how many sacks of wheat or something has come. Vivek used to call 100 times, whereas Surya comes in and he answers everything in one go. So that's a perfect explanation about direct instructions and doing something with your indirect instructions. So that's the intelligence that you have that to do a task completely, what all information I need and how I can do it. So machine learning, so there is always a what's a clash or some confusion that what is artificial intelligence and what is machine learning. So artificial intelligence is a whole big umbrella. Like anything that comes under that is artificial intelligence, and machine learning is just a small part of it. It's just a subset of it. Okay, so machine learning is where you try to identify the patterns within the data. And how many of you are aware of something called generative AI, which is a big talk of the town right now, and wants to even learn about it? How many of you have heard about generative AI? If you have heard about it or if you have used it, do let me know. Probably we could plan another session on generative AI after this bootcamp. So, okay, coming back to this. Yes, AI, Rahul, I guess, yeah, Rahul has pretty much put up a good explanation. So, yeah, AI is a big umbrella. Your machine learning and deep learning are a part of it. Okay, so it's a subset of it. What is generative AI is that instead of your machine learning models are like, we'll talk about generative AI a little bit. Okay, a lot of people have used. So chat GPTs, BART, your stable diffusion, your how many of you have worked with stable diffusion models or even your mid journey, DALI, right? So I think everyone has an exposure. Oh, good that someone have already started coding with Copilot. Amazing that you already have pretty much of experience here. So so you guys, though you are new to it, you already know a bit about what is machine learning. So little bit of. So now if you ask me what is about machine learning, you give some input. What is a conventional way of giving you to do something? For example, let's assume I'm going to uh, tell you to write a program for x square. Okay, so your input data, let's assume it can be x. Your program is that multiply your x with an x. So the algorithm is that x into x is an algorithm and your output. So now if you pass 2 to that program, it will give you 4. If you pass 3 to the program, it will give you 9. If you pass 5, 25. Now let's take a machine learning as your example. So this is I'm explaining for those who are very new to machine learning. Okay, so try to listen to this quite carefully. You might get a grasp of it. So you know how a conventional programming works, right? So you have a program algorithm, something happens there. Now what I'm going to do is there is a program or there is a mathematical algorithm. Okay, something is there. Instead of me coding that algorithm, what I'm going to tell to that algorithm is that, see, I'm not going to tell you how to learn. What I'm going to tell you is, I have some question and answers. You figure it out. So what I'm going to give is, I'm going to give 1, 1, 2, 4, 3, 9, 4, 16, 5, 25. Okay. So I'm going to give that to your machine learning model. Yeah, I guess we have received huge number of responses. Thank you so much for that. Yeah, AI capable of generating outcomes with simple prompts. I'll come to generative AI probably after we discuss about what is supervised, unsupervised, and all. Probably that will give more explanation. So coming back to the basics again, I'm going to give you. I have given the machine learning model that See, this is a input and output pairs that 1, 1, 2, 4, 3, 9, 4, 16, 5, 25. Now you figure out what's the relationship between your input and output. Okay, I'm not going to tell you anything. It's your things to bring it up. What your machine learning model does is that it takes those your input and output, and then okay, so let me try with the hypothesis that the relationship between your input and output is 2x. It's going to assume something. Okay, hypothesis is where you don't know whether it's the right thing or not, but you assume that it's going to be right. Okay, so 2x, your machine learning model decided that the relationship between your input and output is 2x. So let's try it out. So now if I pass 1, it will give you, so I guess I'll write few things up as well. So if I give you 1 and it will give you 1. So the formula is 2x. Okay. So now what I'm going to do is I'm going to give 2 and it will give you 4. Now that actually satisfies our condition, right? So 1, 1, 2, 4. But when you give 3, what it does, it gives 6. But what actual answer we have? 9. So now your machine learning model learns that how much of a difference of error that is happening between your prediction and your actual data. And then it again tries to come up with, let's assume I'm going to come up with 3x. Now I'm feeling that 3x is going to be the right one. So one will give, this will give you 6, but this will give you 9. There is some error, but there is no error here. So it will try to learn the errors and those stuff for all the inputs and outputs. And if you give 3x, 2x as your this one, your accuracy of prediction is only like, let's assume only we have 5 digits, 5 inputs. That means your accuracy is just was 40%. It was only able to get 2 things right. Correct? It's very bad. Now, suppose like somehow your machine learning model has come up with a relationship that it is x squared, then it is correct. But now you must ask me a question that 3 into 1, it's 3. Yes, correct. Vishnu is, yeah, 3 into 3 is 1 is correct. There is no error, but if we try to consider for all other inputs, now there will be an error, correct? So, and now let's assume your x squared. So it's 100% accurate. So it have matched the algorithm and the hypothesis. Both the algorithm and the hypothesis have become equal. But is it possible in real world scenario? Now in real world scenario, you might not just have one input and one output. Now you might have some n number of inputs and one output. Possible, right? Now, how we are going to make a relationship between about all the inputs and this output and all the inputs in the row wise as well. So different types of inputs. So this is where your machine learning model tries to figure out the patterns of data. Now let's go back here. So now you might understand this particular definition. That is a process of using mathematical models, right? We use mathematical models, correct, to establish the relationship between. And it helps a computer to learn without a direct instruction. So we didn't explicitly tell it to try with 1x, 2x, 3x. And Renuka actually asked a very good question here. So I'll bring it up right now. So what Renuka actually asked is probably this is a question for everyone to think about. So how does a model that is has to try with 1x, 2x, 3x? Who feeds this relationship? It's an absolutely amazing question. Anyone in the chat tries to come up with answer? So the answer is that who actually feeds those relationships? So for different scenarios, people try to model different mathematical algorithm to try to establish a relationship. Okay, so a way how your linear regression works is completely different from how your other thing works. So there are three ways how it decides on those hypotheses, how it tries to establish some function. Okay, you need to establish some f dash of x, right? So it depends on three things. So one, the mathematical model of that algorithm itself. So for example, if it's linear regression, it tries to establish a straight line and it calculates the error. That is one. And second is, I guess Edward answered some answer. So Edward says that it's a loss function. And one more person, Dilly, says that it's training data. And Karthik says it's a past data. So which is like the historical data. Okay. So there are training. That's right. Okay. So the answer is that it's a cumulative of all those what people said right now. First of all, the mathematical model, how the model tries to learn the data is one influence. The second is the loss. So based on some the mathematical model of the data, it tries to establish the loss function between your predicted and your actual, so that it would correct back your mathematical model. So that's a feedback that it gives back to the model to change it something. So here it's a feedback loop that comes all the way along. So your historical data influences your mathematical model, and your output, your prediction, again influences back your mathematical model. So that's how it keeps changing after every single iteration of data, and it finally feels that okay, this is where my loss is minimum, and my prediction is much more accurate to the real world prediction. So that's how it tries to do it. So very good question. So if we wanted to dive even more on that, we need to go for graphs, statistics, local minima, global maxima, and everything. But probably we would keep that mathematical discussion for some other day. But I really appreciate Renuka for bringing that question, sir. I don't really hear this question very often in very rare scenarios. Thanks that you brought it up. Very good. So now go back to the basics of machine learning. So fundamentally, there are like three types of machine learning. So what we have seen right now is that we have input and output pairs. That is called supervised learning. Okay, so it tries to establish a relationship between your input and your output. Now comes unsupervised learning. Okay, so unsupervised learning is that you have some input data, but you really don't have any output to map to it. Okay, shall we take one example for unsupervised? Today, you have a lot of people commented out that I am very tuned to machine learning, and few people said that I have experience in machine learning, but not in cloud. There are few people who answered that I have experience in cloud, but not in cloud ML. And there are few people who have experience in complete DevOps expert, but wants to switch domain. So here we can make clusters of people on some similar grounds. So grouping on experience is one such way. Now imagine you have a huge database. Okay, I want to cluster people, or I want to cluster the data points without having a structure or label, but I wanted to establish a relationship between clusters. So that's unsupervised. And reinforcement learning is that, I guess, very basic example is how you train your pets, or how a baby tries to learn a language. So it does not know anything. You start speaking to your baby, or even let's assume your baby wants to start how to learn how to walk. Your baby tries to get up. If the baby tries to get up properly, you try to encourage it, you support it. If not, you give some penalty, or you say that it's not the right way. Do something like that. So with the constant feedback of reward and penalties, that's how you try to reinforce the way how you want to learn, and it goes on. So these discussions again, probably if a lot of people wanted to deep dive into basics of machine learning, you could have it as a separate session. But with time constraint, let's move on again. So what are the benefits? Yeah, correct. So Dilly said it very well. So it's a supervised learning is a training models with label structure. And yeah, trial and error with reward and penalty. Yes, absolutely, that's correct. So what are the benefits? So it tries to uncover insight. So let's assume that today, if I gave a clustering problem about based on your answers, that I'm experienced in this, I'm experienced in that, it will help me to uncover the insights that these are the clusters of people who are new to machine learning. These are clusters of people who want to learn something like this and so on. So this is a benefit. It helps your data integrity. Take your Bing website or your shopping e-commerce, any e-commerce website. So it tries to recommend the object that you want to buy. When you say that if you buy one object, it automatically recommends that buy this product also, because most of the people who bought the product A also bought the product B. That's how they enhance the user experience. And if you very well notice, it's also anticipating a customer behavior. If a customer buys an product A, they very well know that they try to buy the product B also. So they try to establish a relationship. And that's, if you put it in an overall scenario. So if you try to save or you try to minimize those little stuff in a business, you try to lower cost in a very big aspect. So that's a benefit of machine learning. So what are the stages in machine learning? So though today is in Azure ML, we are not going to deep dive into all these processes, but for the sake of the basics of machine learning, I'm going to say what are the stages in that. Especially for this is a way how you need to start your machine learning journey if you want to. Take one data set, okay? So how you can find the first one is your data collection and pre-processing. I said go and collect a data set. Where you can find it? You can find it in internet, you can find it in Kaggle, you can find it in any data source, or it can be like, it can generate from some hardware IoT device also. Or if it's a weather forecast, it comes from your forecast, your weather monitoring systems. So data, you need to identify the data source where your data comes from, and you collect and keep it in a organized manner. So put it in a CSV file, or you make it as a database, or you wanted to structure the data, you structure it. Then what you do is, the real world data is not clean. So it has a lot of missing values, or it might have wrong inputs, or there might be a situation where it wouldn't have collected data for some time. So you might have lost some data. So you need to identify all those and clean it. So what are the different ways to clean it? There are imputation methods, sampling, and everything. Again, not much into details. The second thing is training the model. So once you have taken the data, you collected it, you cleaned it. Somehow you made it for enough for your model to train upon. Now what you do is, you try to, and also before you do that, you try to transform the data in a better way. So if you have a text or string content, usually a machine learning model struggle to learn that string content. It does not work well. So if you try to encode the string into some numbers, it's much more better. And there are some rules for you to encode it. It's only applicable if you have your categorical data. Only when then you can encode it. So those all thumb rules, you try to have a clean data, and after that, you split the data into training and validation. So now today I told you, right? So you ask your model to try to learn something. Right? If I give 1, it assumes that the hypothesis is 2x, so it gives me 1. So it needs to learn from a data. That okay, this is a 1, this is a 1. I learned something. Now your model, let's assume that your model have minimized your whole loss and brought up with the hypothesis function, that is your f dash of x. Now to check how it works in your real world, you give some unseen test data. Similarly, how your school exams work. You learn something, you have 10 questions, you learn everything, now you feel that you are an expert. When they twist and ask you in exam, then how you apply all these learnings in your twisted question is where your learning comes into picture. So how your model performs well in validation depends on how well that mathematical model, and how it learns. If not, we'll keep on improving it. Okay. Once you're finalized with the model, what you do is you try to deploy it and run it. Now comes the important question over here before we move to the next section. How many of you here have tried to deploy a model? Instead of like, I'm sure that people who have started with machine learning probably would have crossed these 3 stages. They have made some predictions as well, but have they really monitored, or they have really productionized it? Like keep the model somewhere. You send a REST API or web link, and it sends back the response. Like similarly in ChatGPT, right? You just type something, and your response comes in some response, right? How many of you here have done that? No, I am only using Flask. Good, that's one way. But Hamid, have you deployed your Flask application, or were you running it locally? So Flask is a Python-based framework, so where you can run your Python frameworks and all. So I guess a little bit. Okay, Ahmed. Okay, you have run that in this one. So Ananya says that no. So most of the people would have just stuck to the notebooks. So today, what we are going to see is we are going to go beyond your notebooks. Try to uh, deploy it. But I guess Rahul, Amar, Ramanan, Edward have all. Yeah, Edward. I know Edward for a long while, so I know he's good at that. Okay, so Karthik, Adesh. Okay, so now these for the people who have replied that you have deployed your model. Now I'm going to post you a very next step. That will be one of our outcomes of today's bootcamp. Not just because you are able to deploy it doesn't mean that you are able to accomplish the production level sort of a use case. Today we are going to really see that. Okay, you have deployed your Flask application. Adesh, then what you could actually do is, if you have already deployed your Flask application, today you're going to learn about how to deploy a machine learning model, and you can go and integrate in your Flask application and you can do it. So demo one, I'm going to skip this demo. It's just running your machine learning model in your local. I guess pretty much most of you have done it. If not, just go to Kaggle and run any notebook that works. So for time constraint, let's move to the next section about Azure Machine Learning Service. So few people have used Heroku. Good. Okay, there is one. Okay, I'll take up one question from Shanmugha Kumar. Is ML will integrate with IoT devices as well? I'm not getting the full context of the question, but let me answer it. Uh, in real world scenarios, a lot of data, real world predictions the data comes from IoT devices. So it might be monitoring devices or anything. It might be mostly time series data. So IoT devices generate a lot of data for your inference actually. So how can ML integrate well? So one of the primary data sources for machine learning in inference comes from IoT devices. Maybe the other interpretation which I'm trying to analyze here is that whether your IoT devices can run machine learning models. Yes, it is possible. Edge-based machine learning. Okay, yeah, exactly. I think Edward helped me out here. So yeah, it's called edge-based machine learning, or it's called embedded machine learning, where you have some microcontroller or a very low-powered or low processing power thing that comes along with your IoT devices or a couple of IoT devices that process your data locally and then sends the inference along to your cloud or your local server or anywhere else. So that is possible. It's edge deployment. Yeah, Vignesh also is like it's edge deployment. So I think that answered your question. Now comes a question. So why cloud? Why I need to pay or why I need to use Azure Machine Learning Service here? What's the big deal? So people here have done a Flask application, correct? A lot of people have deployed your machine learning in Flask. Now this is a question for you. What you have gone for your Flask application, you have hosted in AWS, that is the different stuff. Your AWS or Azure, that doesn't matter. You hosted in some cloud. But for machine learning service, why should I go for cloud? Any doubts? Or what are the difficulties that you faced while running a machine learning model? You can post these questions in comments, but this section is where I'm going to dedicate that for explaining the whole stuff, why we need to have it. Exactly. Rahul, I think one word answer is that your infra and your platform is provided. Very well. That's a fundamentally that's an answer for that. But let's deep dive and understand why using that infra as a platform is one of the best ways to do it. Okay. Compute power, And see, my system, my Mac, I don't use it much for my machine learning services. I just go for cloud every single time. So that's there. Correct. Again, compute power comes to your infrastructure, platform, managed services run on your platform, improved inference performance. Absolutely. Yep. So now let's try to, for people who are trying to understand, like why do we need to go for cloud? What's the necessity for it? Let's try to answer that. First of all, this is the exact reason. This slide is the exact reason why people go to cloud. Or just having a machine learning application running in your instance does not mean that you could be able to scale that to 1,000 people, 10,000 people, or millions of people. Exactly. Your storage and your compute should be at scale. So not just that, just not just your platform and your resources. There is something more than that. Auto scale, of course. Uh, there is a question from Geeta. Would you like to help me know how Azure ML services are different? Uh, I would not take that in today's session to do a comparison on AWS and Azure. But do ping me personally. I would like to or explain you on that because today's session is more towards Azure machine learning. Let's stick to that. So this is a challenge. So let's not consider the word about MLOps. Okay, I know there is an ops expert in today's session. I think he will validate whether I'm saying it right or not. So you have resources. For example, you have your compute resource. Many people say they have your storage resource. You have your data sets, right? And when you work with your data sets, you try to apply some functionality to it, and you transform the data. And then second is you apply more and more transformation, and your data gets transformed. But how do you keep the first version of your data and your last version of your data available to you? Yes. So you need to version your data. And second, compute. Let's now assume that you are able to run a machine learning. You're going to train a machine learning service. You're going to train a simple SVM. And in your organization, there is a person who's going to train a LLM, like a big model, or deep learning model, something. Okay, like a ResNet or something. He's going to train the complete ResNet. So how are you going to manage your compute for you and that person? How are you going to make it much more efficient so that you don't occur much more cost? And since, for example, now that you are a machine learning engineer who is going to run an SVM. So for SVM, what all you install? You install scikit-learn, you install pandas, blah, 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 correct? Now for that same person who's going to implement a ResNet in TensorFlow, he's going to install Keras, TensorFlow, and everything. How are you going to manage the dependencies of your SVM person and your neural network person? And for example, now your manager, your boss comes says that the deep learning person go and work in machine learning, the machine learning person go and work in deep learning. Then do we need to really reinstall all these libraries, or is it possible to share? Yep, that's one challenge. And for persons who try to evaluate which model is the best. So there was one question from Renuka, right? Where how does your model decide which is the best accuracy, correct? You keep on experimenting it. You keep on running to see where your loss minimizes. You try to hyperparameter tune that, and then you see still it works. So who is going to maintain the versions of your for one version of your model and your nth version of your model, correct? And then you decide that okay, my sixth model performed better than the 50 models I tried. Now I need to pick the fifth model and deploy it. How am I going to pick the fifth version and deploy it? And that is another question. And the next question is that if I'm going to deploy that fifth model, how am I going to monitor whether it performs correct or not? Probably it might work well. What if down 10 days, the model is giving very bad predictions? How are you going to monitor it? And this is where your machine learning. So now comes, I'll explain. There was one person on asking about session on MLOps. Sure, we'll do it. Yes, MLOps is ML operations, correct? Now, let's talk about why that operations comes into picture. So, any ops like DevOps or anything, if you introduce automated pipelines to execute some roles or execute some jobs, and if you could version every single aspect of your artifacts. So your machine learning model is an artifact, your data set is an artifact. If you could version every single aspect of it, and if you could streamline that in a pipeline or something, that is called an operation. So if you take any, like if you take a supply chain, like for example, if you are ordering your Swiggy or your, I'm sorry, if you're ordering any food delivery app, if it comes from your restaurant to your home, they have streamlined that your person should reach your restaurant, collect the order, take us by, come to your destination, deliver that, and mark is complete. This is an operation which comes in a pipeline, that a streamlined operations. Exactly, if you could run these operations, if you could reuse the operations, if you could automate it, and if you could version it, then you have accomplished the operations part. If you do it with respect to machine learning, it's called machine learning operations. Well, then what is a DevOps? Then if you could do that in respect to your coding environment as well as your build and your deployments of your websites or any software tech stack, it's called DevOps. So that's a whole difference between your that is the MLOps. Now for folks now you have who have run some machine learning models in your this one. If you go now, I would recommend that at the end of this session, just go back to your machine learning folder and see if you had maintained V1, V2, V3, V4, V5, 10 versions of your machine learning model, or did you keep on overwriting it? How did you manage that? This one. So go and see it. That's where you will clearly understand that if you scale it to an organization of 100 people, 1,000 people working in machine learning, now that makes much more sense. And now comes a big question. Who's going to manage those versions? Who's going to give you those automated pipelines? How are you going to do it? The answer is yes. Azure Machine Learning Service. That Azure Machine Learning Service helps you to streamline the complete machine learning operations that you wanted to do so that you could accomplish your task. Exactly. Ananya, maybe that's where you were overwriting it, right? So this is exactly where you need your MLOps. And it's not necessary that MLOps should only run in cloud. You could run that in your local as well. So if you install any MLOps client like MLflow in your local system, you could now also version your data set, your everything. But there is a huge difference. There were persons who actually told it: storage, compute, and the platform. Those infra and the platform which a cloud provider gives you is very immersed, and you can use it, and you can pay as much as you use it. Correct. So I think I'll take up this question from Geeta. So when you are using multiple models subsequently, I guess that is called transfer learning. How do you decide the order in which model needs to be applied to get the right outcome? So using subsequent models is not necessarily needs to be a transfer learning. The reason is that the definition of transfer learning is where there is a model which learned on some data and you want to transfer those learnings into a different data set. So for example, your machine learning model has tried to learn 10,000 varieties of shoe models. If you're trying to bring 5 new shoe models, instead of asking the machine learning model to train on the new 5 models, you just try to transfer those learnings and try to figure out the last 5 shoes. I guess I'm not confusing you, but yeah, this is a glimpse of it. You try to transfer the learnings of your bigger data set to a new and a unknown data set so that you don't have to retrain it completely. So that's called transfer learning. Maybe one way we could also see this question is where it's not the order, or sometimes there is something called ensemble learning where you decide which model's outcome you want to take. For example, if you have 3 models, you can use the 3 models as an ensemble, and the best outcome of these 3 models will be taken as a final output. That is ensemble learning. That is more like a parallel, I would say. Sequentially, I'm not really sure what's your question, but transfer learning is the definition of it. But I think if you have further questions on that, probably we could take that offline. But yeah, that's a overall. So architecture and terms in machine learning. So now we have seen a lot of talkings, right? So what is the architecture? Okay, my voice is passed. Does anyone have the same? Hmm, I guess so. It's working. Okay, it's perfectly fine. Then I guess probably who was it? Karthik, probably you can just check it. Okay, it's working fine. Okay, thanks. Right, your architecture in terms and machine learning. So there are three ways to do it. Okay, thanks, Karthik. So there are three ways, like multiple ways to do it. One is where people like us who don't want to code completely, but just wanted to have everything on GUI like a website. So that's called Azure Portal. There are again two ways to code it. So there is a machine learning studio where you could use the UI and also you can code. Or if you're a person who does not want to code or you don't know coding, but you want to still accomplish the complete benefits of machine learning, so they have something called machine learning designer. So it's just a graph you can just drag and drop, and you can still do the entire machine learning workflow without one single line of code. This was also one we had one in-person session in Chennai on Azure Machine Learning Designer, which was delivered by me. Probably we could do the redo on session on virtually as well, so that if it most of you want that. The second one is CLI. So everyone knows what's a command line interface. One of the dreadful ways to use it. But if you are a person who works in cloud form like cloud formation or like your infrastructure as a code service, then people stick to CLI. I guess other than that, I don't much prefer CLI myself unless I'm doing some OS level work. No. And the third one is a quite favorite among the developers. So you have an SDK. SDK is where your software development kit. So all the functionalities that you want to do is wrapped up in Python or some programming language, and you can use it. So how to use that Python SDK? Yes, you can go for ML Studio, or you could run it in your VS Code with Azure ML extension, so that you don't want to go to this one. And I guess that any other IDEs along with it works. Yes, that is Terraform, but yeah, I think most of the folks in cloud who use that is YAML and CLIs is that. I don't use CLIs much. Okay, now let's move to that. So I'll give you a little bit of uh, overview about how that looks in architecture and terms wise, but it would be much, much more better and easy to understand if we see it visually. So we'll go to our machine learning portal and then see from there. That's much more better. Okay, and then we'll come back again to learn what is what. Okay, so you have free trial for 1 month. So anyone who wants to start your mission like your cloud can just go for it. This is my personal account, which I'll again ditch it very soon. So you will get a free subscription for 1 month. You can use it, and please be mindful that not all services are free. There is a free trial, and there is a free trial for every single service. So before you go ahead and use the services, make sure that it's a free trial. Okay, that you can do a little bit. Just search upon the cost and everything. You will get all the answers for it. So a basic explanation about Azure services, how it looks. This is your account. So this is your complete management account. One single management account consists of lot of subscriptions. So right now I have two subscriptions here. Okay. And those two subscriptions are of different payment roles and everything. So that is subscriptions. Under each subscription, you can have something called resource groups. And before knowing what is resource group, every single service that you see here is called resources. So it can be your virtual machines, it can be your Azure machine learning, it can be your app services, everything is a resource. If you group these resources, like for example, I wanted to logically group, like I want app service, VM, and something to be called as a Vivek dev environment. If I keep that as a group, then I'm logically doing it, so which is called resource groups. So it does not have any meaning, but for the sake of visualizing for you or the sake of ease of use of those services, you just group it for your convenience. So that's called resource group. These are resources, and this is a subscription. Under subscription, there are resources. So it's a very basic outline about this one. Now let's go to machine learning. So go ahead and create a machine learning service, or it's called a workspace. Just go and create it. It will ask you a bunch of questions like what region, storage account, and everything. Just fill up. The rest will do. So once that is done, go and launch the studio. There are a lot of issue, like there are a lot of inner details um, IAMs and everything. Probably today is not the right day for us to deep dive on that, but yeah. So the folks who were interested about generative AI, I guess there is a you can actually do a lot of generative AI stuff. They have brought in some ready to make models on generative AI. You can try it out, but today, not today, not today. Today we are going to do something else. So here, what all information we have here? So I'll change my appearance. So I guess no, this is very big. Sorry. Okay, this is better. I'll zoom it in so that it does not hide. Sorry, I'll launch it again. My bad. So we have notebooks. So everyone is aware of some Jupyter notebooks, right? So where you can run some code in that. Automated machine learning, we have that in our bootcamp's curriculum. One line about what is automated machine learning. I told you that a machine learning process has like data pre-processing, collection, and training, hyperparameter tuning, and validating. You have to write code for at least each stage. What if a service is there that will do everything for you? That's automated machine learning. We'll learn it at the end so that we know how it's being used properly. Okay. So then we have designer. So I told you that designer is for people who doesn't want to code, but they can do it in way of graph. That is a designer. These are, and something called assets. We have data, jobs, components, pipeline. Data is where you have data. Jobs is like every single thing which you run in machine learning is called jobs. Like training job, inference job. Everything is a job. If you want to clean something, your data, that is also a job. Validating that, also a job. Pipelines, if you streamline that, then that makes sense. Others has some, I'm not sure of it, but others say that GSDP has 100 precredits. I'm not sure about that actually. So maybe you could. Okay, it's GitHub Student Developer Pack. Yep, Others maybe if you could post more info on that, that link to the GitHub Student Developer Pack, probably people will be helpful of that. Can you please kindly do it for me in chat? So yeah, you'll get 100 free credits, so you can use that. It's much useful. Environments, I guess we talked a little bit on the environment. So environments is nothing but a place of couple of dependencies so that you can run somewhere. Yes. Adesh, can you paste the link of GitHub Student Developer Pack so any students or college people can apply for it? Please do that in chat. And models, versioning of model. I guess Ananya told that she never made versions of model. Here you could actually you can keep the versions of model. Endpoints, when you deploy it, right? So deployments are called endpoints. So if you use ChatGPT or something, you type something there, and then it goes to an endpoint, does the inference, and it gives you the response, right? That is called endpoint. And management, I guess this is where a lot of people actually answered. So compute, your storage, and everything is managed by Azure. So there are other managing services which it's not concern of today right now. Cool. So yes, so this is the outline of how a machine learning ML. Oh, I'll include the. Okay. So now let's go back to this one to understand what it has. Now it's pretty much easy for us to grasp. We have a machine learning workspace. You have linked services of your data and your compute, correct? You manage all your compute instances like your clusters, and there's a slight difference between it, but let's not worry. So your compute targets actually manage your instances and clusters. There's a very minor difference between an instance and a cluster. We'll see about that as well. How your workspace is dependent on, so there is a storage account tied to it. There is a container registry. There is a key vault. There's an application inside. And what all your workspace provides? We have seen datasets, models, endpoints, pipelines, experiments, and environments. So we'll slightly see what it each means as well. So workspace is that everything under that machine learning service is called a workspace. Now you can imagine, I'll try to compare the terminologies of your machine learning to your chemistry lab. Okay, it's a weird analogy, but I think that makes much more sense. Let's imagine your school or your chemistry lab is your workspace. Okay, so anything that comes inside your chemistry lab is a workspace. So your data sets, now in machine learning, any data set, compute resources, anything that you do over there, it's a workspace. Okay. Experiment. So in a chemistry lab, you as a scientist, okay, you go and you do some chemistry experiment, probably a titration. So titration, I guess everyone would have done it in your school days, right? School or college days. Yep. So experiment is where what is if what you call an experiment in your chemistry or physics lab is that you define an outcome that I want to achieve something, and you actually keep on what you do is uh, try to run something like you take some inputs, your chemicals, you do mix something, and you try if you see you can keep the outcome, if you can achieve the outcome. If you're not, you redo it. You again redo it. So every time you redo is called a trial, correct? And the whole complete number of trials is called an experiment. An experiment has an outcome. For example, today I want to complete a, now let's talk in terms of a machine learning, Azure machine learning. So I wanted to experiment. My experimentation goal is that I wanted to create a model for diabetes prediction, like iris prediction, any prediction. Okay, keep that. So I write a script. I try to bring the data. I try to version the data. I try to clean the data. I do the scripts. I keep on trying, and I train it multiple times on my compute. So, and the final objective is that I create a model and I can track that under the workspace under the name of experiment. So anything under that pipeline is called a bunch of pipelines or bunch of scripts. It's an experiment. I guess that very well correlates with your chemistry experiment or physics science experiment. So now comes your run context. A little bit, yeah. If you just take one run, okay, the first run is that in your chemistry, let's assume that you add some chemical A, chemical B of some quantities, and you expect a outcome, or you do something on process on that. So that's one run. If your run does not yield you the right outcome, you do the second run, third run, fourth. And for each run, you monitor whether it gives you the right outcome or not. Correct? So that's where every single run inside an experiment or a trial, which we call, is an experiment run context. And that can be tracked and it can be validated and can be quantified, that you can monitor and you can have some metrics surrounding that. So that's an experiment run context. So I guess pretty much we went to demo two and then we came back to this one so that we don't get bored by the definitions and the blah 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 talking, right? So I think now everyone has an idea about how to create a workspace and what to do. Okay, just a reminder again. This is our GitHub profile, which has all those details. So we have your social media contest running, one. We have the notes, best knowledge share also going on. And if you're not filled your attendance, feel free to fill it. I'm not, feel free to fill that. I guess we already have received quite a number of submissions over there. Okay, almost 60 plus submissions over there. Good. Let's keep it that way. So if you have not filled your attendance, just go and fill it. Then, okay, so before we go to the third section, I'm actually let's give a little bit of a break. Navneetan, I'm adding you to the team. So can we have a 5 minutes break before we convene in? Yes. So meanwhile, feel free to go to your social medias, do tag, spend some time to post about it as well. So we'll come back in 2 to 3 minutes. So we'll take some rest as well. And I'm here to take the questions. If you have any question on side by side, I would be happy to take that. So I'll just go around and see if I missed any. Yes. Meanwhile, there is a break. Let's talk about something called little bit of an off topic, generative AI, right? So I told that I'll talk about it a little bit. Uh, and of course, if anyone wants to take a break, feel free to do so because we'll come back in 5 minutes. I'm just giving a little bit of a break here. And generative AI. So what is the difference between your conventional way of doing it? So you have supervised learning, you have unsupervised learning and everything, right? But it tries to establish a pattern between the data. But what if there is a machine learning model or some AI model, something that learns some data? The data input data can be your text, audio, video, 3D models, anything. And based on that, it's able to generate a new content of the input. Based on the input, it tries to generate a new content as an output. The output necessarily not be the same as input. It can be a image, text, video, audio output, 3D models, anything. So if you take stable diffusion, so text to image, right? So is that okay? SM tags. I'll just post it again. The tags for it. Meanwhile, I'll just skip to this one. Yes. So if you could generate a new content from the existing uh, input, then that is generative AI. So I guess from the word itself, it speaks that it generates something, correct? So it's a generative AI. So if it has an input of text and it gives you an output of image. So as Giliraj says that stable diffusion is a text to image. Very well said. And same as that, we have image to image. So you give an image as an input, you generate more. That is called image to image. We have audios. Generative AI is also right now is everywhere. It's in Photoshop and everything. So even Photoshop has generative AI. So there are multiple use cases. We could have a special session on generative AI and also try to deploy a generative AI model in this one. Uh, yeah, just to give a glimpse on that, how generative AI works, Ananya, for you, I'll give one just simple explanation. Usually, any generative AI is consist of two neural networks. One is generates something, and other one tries to diffuses or what's it rejects it. More like this one. So it creates a noise. It like the first neural network tries to get the data, adds more noise to it, and the second neural network tries to remove that noise and generate a new content. So what if I could use some good analogy if that's the case? So like it's more like an improvisation, if you could say. Like you give something, you add more to it, and when the second person takes up and does something based on top of it, it becomes a new content on top of that. So just to summarize what how a generative AI works, uh, if it's a like if let's take stable diffusion as one example, your first neural network takes an input, puts some noise to it, and a second tries to remove the noise. By removing the noise, it creates a new content or new version of the input. So that's how generative AI works. That's a very simple explanation about how generative AI works. So yeah, as Dilly said, like there are it's not just GAN who's a generative AI model. There are a lot of stuff. GANs were the first, like one among the first. So it came the research paper came out in 2014. And GANs we have variational autoencoders, VAEs, then we also have stable diffusions and so on. So now there are plenty of models for that. And you could also tweak and deploy your own machine learning model. So, and one more question. I guess we'll take two questions and we'll go back to the session here again. Do we get a confirmation email of attendance? So, Vishnu, how it going to work is if you attend the 2 days and once you fill those, your batch, day one and day two, you will get a digital batch through your email. The link to your digital batch will be through your email. So you can consider that email itself is a confirmation email of attendance. Suggest some open AI to generate code. So it's called Google Copilot, where you could generate code from your AI, generative AI. So one possible way is we could have a separate session on GitHub Copilot, sorry, not Google, GitHub Copilot that generates your code. Yes, please do post about our event. Use our tags AZDevTN or Azure Developer Community TN. Do specifically tag us. That's how we'll be able to track you. And how your social media contest wins based on the number of likes and shares on each day. We'll give two different this one and winners on LinkedIn and Twitter. So general question: what's the right learning path for machine learning? What type of certifications are there? I think I'll take this question at the end. This is a good question as well. So it will have a lot of it'll try to answer a lot of people who have the same question. So I'll try to take this question at the end. Any practical use case? So we have a lot of practical use cases, right? So your customer support is able to now you can do it. You have image generation, you have music generation, you have code generation. Your tools are already available over there. And what else you have? Simple example. Okay, yeah, simple example. Yeah, Microsoft Bing. Yep. And chatbot summarization. Yep, I think ChatGPT is one such tool which does it. Yeah, chatbot is one very good example of actual generative AI. Back then we were using chatbots without knowing that this is generative AI. That's a reality actually. Okay, now let's go back to our session. Probably you have settled down, so we can go back and start the third part. And I can assure you that the section 3 and 4 is going to be very short. It's going to be more like a demo sessions probably. So we'll quickly go through that. So bringing data to Azure ML. So I'm not going to, there are a lot of ways to do that. So I'm just going to pick up one or two ways to do it and stick to that for now. But before that, let's try to learn what is available in Azure Machine Learning. So if you go to your machine learning workspace, here there is an asset called data. If you see here, there's a data asset, data stores, and data monitors. And there are a lot of something over here, correct? So data stores are nothing but, I'll take this out. Okay, so data, what are data stores? So conventionally, how do you keep your machine learning data sets? You keep that as a file, correct? Or you keep that in some cloud storage as well. So for example, if it's in Azure, it's going to be your Azure storage account, or if it's going to be in database, it's going to be SQL or somewhere. Somewhere you keep your data somewhere. But the way you access that data, correct? So if it's a storage account, then the way you access the storage account and the file is different from how you access a database, correct? Now, data stores is where it's going to bring you a abstraction. It's not going to reveal you completely on where it is stored, how it is stored. But if you want to access the data, it gives you a couple of functions and APIs. Just call it, you'll get the data. So that's an abstraction that data source has. Like it manages your data. Okay. So instead of your connection information, if you want to write the database, like you need to write your connection information, like your connection string, passwords, you don't have to do all these stuff, right? So your data stores eliminates all this and makes it much more easy. And how can you actually create a data store. Okay, so you can do it in two ways. One is credential based. It's a little bit of Azure terminologies, but if you're new, feel free to skip it. It's not much important for you to deep dive and learn right now. But yeah, SaaS or account key or authentication, or you can use a AD identity. So people who have been working in Azure ML can differentiate it. But if you're not, feel free. It's not a bigger deal right now. Credential based, so how you can actually do is in credential based authentication, you can have a service principal. So service principal has that credentials for specific resources, and you can actually make it granular that I only need to have it this one. So what is difference between vector store from data store? I'll try to take that question a little later. So coming back, so what is a shared access signature? So it's like your token that you usually use. Like for if it's an auth token, you might know that, right? So it's more like that. So so it's that your shared access token for limited resources for limited number of time. For temporary access, it's very good. Account key is like more like a you can have a primary account key, secondary account key. Service principal is the best way to do it. But if you don't have, so yeah, manage identity. So service. Uh, I could explain right now. So managed identity is where the identity is actually in terms of it. You can configure the what resources you want to access, which resource you want to access, and what type of action. Like if it's a read write, both ownership and everything. If you can define all this, and you can connect those one service to another service that it can communicate to each other or it can access each other, then it's a managed identity. So if you want to connect your data store to your machine learning services, you can connect it via your managed identity as well. Correct. So Ganesh, yep, that's correct. It's a set of rules that how you wanted to access it. That's primarily how a basic authentication works. And identity based, this is where your identity based authentication works. So it's like you have AD credentials, or your Azure manages the complete creation and it handles the complete credentials. So if this is the case, you have to maintain your SaaS token by itself. But if Azure can maintain it for you, it's more like a managed. So identity. What's the best practices to have a data source security? So don't use credentials in your scripts and notebooks. First thing. Okay. And you can use credential-based authentication only when it's necessary, and prefer identity-based authentication. In our scenario, also we are using a managed identity only, actually. And if you have tokens and account keys rotated from time to time, basic security things. And this, besides data stores and every single data what you have there, it's called a data asset, and that data asset can be accessed via public URLs as well. Okay, you can make a data asset from your either from your storage account or from public URL or from your local device. You can upload it and make it as a data asset. You can use this data asset in your learning jobs, so in your machine learning jobs. So today we'll be actually accessing an open source data set available in Azure directly, but I'll show you before that. I'll show you how our data stores are there as well. So this is one thing. So one question which was early posted is that how when I change a data format or when I try to do some transformations on a data, how could I ensure that I keep the original data intact? And also how can I create multiple versions? So data assets can create multiple versions and you can maintain it. Okay, so then you can decide which model, which data version that I can need to use for my model training as well. So there are three types of data set. You can have a URI file, it's only a file, or you can have as a folder. Because folder, for example, if it's an image based thing, you can have 100 files of images. Yeah, principal, yeah, service principal is mainly for CI platform, correct? And managed identity, system assigned and custom. Yep, it has two different way of doing it: system assigned and custom managed. Correct. And key vault, use key vault, and don't try to have it use key vault. Key vault is the best secure way to do it, right? Manager, yeah, it is using IAM, correct? Yes, it is using IAM. So you are a folder and ML table. There are three ways you can have the data types of assets. But yeah, let me show it. It's much more easy and better way. You go to your sorry, not your data thing, and you can create a data asset directly that, okay, I want to create something. I want to create a file. I can upload it directly from my local. So where do I want my data store type to be? Whether you want to be a blob storage or data lake, it's up to us. Where I want to store my data, or whether I want to create a new data store, I can do that as well. For example, I need to put somewhere in Bootcamp DS. I can do it. I can upload my file. But today we're not going to use this exact thing, but I'm just uploading for reference. Okay. Okay, it might already have a data asset, so probably, yep. So you can directly upload it over here. So it's already here with us. So there are few data sets, there are few data stores as well, and it also has the data as well. So yeah, so these are data stores, these are data assets, and then how you can use it during our training job. We'll try to see that as well. So now comes the end of how can I create multiple data assets which connects to the same multiple data stores, blob storage. Yes, you can do it. You can have multiple data stores and you can have multiple data assets. Yep, that is possible. But one data asset is always connected to one data store, if I remember correct. So if I'm right, that's a conventional way to do it. Because when you upload a data asset or when you create a data asset, it asks you to mention which data store it needs to be stored. So one data asset is always connected to your data store, but you're free to create multiple data assets, multiple data stores. And of course, keep mind on the pricing. Now let's go and train your machine learning models. So everyone now is aware of what is workspace, what is experiment context. We now know what data. The only thing which we didn't see about, do you know what is that? Compute. Yes. So I'm going to show you how you can access or create a notebook in your Azure Machine Learning. You create a notebook. There are two ways to do it. Okay, so either you can, I already have a compute, so it shows me. But if you are fresh and new, go to compute. There are three things. So compute instances, compute clusters. Compute instances like a one single server, whereas compute cluster is a multiple nodes. It has multiple clusters. Right now, okay. The reason is that it has stopped. I'll start it again. You can create a new instance. So go ahead and see CPU. It has cost and everything. That means $0.3 per hour. So make sure that you are going to incur some cost. So please be mindful of it. So I'm going to start the already I've created this compute. I'm just restarting it. It will take a couple of seconds, but yeah, let's just go back meanwhile and discuss our presentation. So the ultimate aim today is that how we could take your ML workflows. So now we understood what the machine learning processes are, okay, and then we know how we need to access the data and what all steps you need to make it as an MLOps. So how you can manage your data properly, manage your data and machine learning properly. So how the final step is to take it to production. Is this instance shared or dedicated to one user? It's dedicated. Sorry, one user in the sense, are you asking within the organization or across the organization? Because there is a difference in another cloud provider as compared to this one. Yes, you can actually for it can be a shared compute within an organization also. It can be a across organization like spot instances that you have in another cloud provider. That is totally a different concept. But within that workspace, yes, within the workspace, it is you can share your compute with your all the users who have the access to machine learning workspace. Again, as rightly pointed out, it depends on the security policy. You can restrict the access of each user of using a compute instance, or you can even restrict a person from creating a new compute instance or deleting it. So that's also possible. I think Dilly said the right answer. It depends on the security group, but the fundamental answer is that you can share it across your users. So today's ultimate idea for me, or if you ask me why I wanted to really take the Azure ML Bootcamp. So most of the folks who are interested in machine learning end their machine learning journeys with just your notebooks in your local compute, which we really don't want to do. The notebook is only for your experimentation, explore data, do everything. But when you wanted to productionize it, there are a couple of things you need to keep it in mind. And today is how we are going to do that. And you need to have a better fit for production workloads, enable seamless interaction. And folks, listen, this slide also comes as one of the question in quiz. So I'm just dropping you a hint here. So how you need to do it, you have a script that you wanted to run in your compute instance. You want to rerun as many times you wanted. You wanted to give some input, some parameters to the script job, like script in the sense, not your machine learning script that takes some inputs and run it. You can schedule that jobs as well. So every single run here is called a job. And you wanted to know how you want to maintain your production environment. I said like we have environments where you can maintain your dependencies, you can reuse the dependencies and everything. So we are today in today's by end of today we are going to learn one thing, which is how are we going to create a training script, an environment, and a command job to run that script. Simple. That's the ultimate aim of day one. Let's do that. So how you need to create a production ready script. Okay. So it helps you to test and automate your production environment. What you need to create a production ready script is just remove all your print statements. It does not make any sense. Refactor your code into as many functions as possible, make it much more modular, and you can test your script in terminals. So it's not a big deal. And yeah, what are the 5 steps we need to do it? Step 1, create a script. Step 2, set up a workspace. Step 3, we have a compute, do it. We need to say where the script needs to run. Fourth one is configure the command job, like what input should go, what output should come, where it should run, what is the environment that it should run on, and where it should submit for an experiment. I said like experiment is a run, correct? And finally, submit the job. Now it seems fairly simple, right? If you see the code, you'll be amazed that what really stopped you from being from a notebook person to a MLOps person with just a couple of lines of code. So let's go and see that. So like it's already here. So what you have to do is your computer is ready. You can access it via Jupyter Lab, Jupyter, VS Code. Go to Jupyter, much more preferable, I guess. Now everyone will feel like this notebook actually runs in your compute. Okay. So I'm going over here. I have a folder. So I have something called training. So let's just see what all it has. Just give me a second. Let that run. I'll just delete a few things over here. So yeah. Oh, sorry. Yep. So first you need to connect your workspace. Just run this code. It has your workspace credentials. Just run that. And second one is where you want the script to run. So there are two things. One is called a cluster and another is an instance. So if you go here and see your compute, so I have created a cluster. So in that cluster, what it shows is that how many active runs, how many idle nodes, how many busy nodes, and how many unprovisioned. So it has four nodes, your four CPUs, four nodes, and it brings up based on the number of jobs you submit, it brings up that many nodes and runs it. Once there's no job, it will scale down to zero, and you won't be actually billed if there is a the active runs or the busy nodes is zero. During the time, you won't be able to, you won't run it, and it paralyzes your jobs, so it's much more efficient. Instance is just a one instance. If you accumulate it and make it as a multiple instances, it's called a cluster. Simple. So, okay, that's the only difference. Let's go to the notebook. And I've already created a dev cluster, but if not, this code will create a new cluster for you. So it's like you already have a cluster named dev cluster, so it won't create it. Now let's create a job environment. Okay. Environment is nothing but your dependencies, correct? So dependencies, I want all these dependencies. I'm going to create a file called conda.yaml file. So overwriting dot dependency slash conda.yaml file. So if we go here, dependencies, conda.yaml, the dependencies are set right now. You can write it opening a file, you can do it from code also. It's up to you. It's just written right now. Now I need to create an environment with that dependency. So environment is where it consists of dependencies, right? So I'm going to give an environment. I'm going to give it a custom name, a description of it, tags and so on. So, but what is a conda file it should consist? So it's a conda.yaml file from the dependencies folder. In production, do we need to have access? So no, in production, if you do wanted to train it, you need to create clusters. But if you want to do inference, inference clusters are different. That we will see tomorrow. That is our agenda for tomorrow as well. So yeah, right question actually. So I'm going to create an experiment, an environment called this one. So the environment name is called Bootcamp exp. So done. Now let's go to training part. So training is that my compute is ready, my environment is ready. I need to create a training script. So I'm going to create a training script. So for folks who know machine learning, if you take a closer look at it, it's nothing but training and splitting. And you're running your machine learning model and logging your and registering your model once the model is trained. So what else is there? Prepare your data. If you want to do more pre-processing, you can do it. Training your data is where you do after you split from here, you just train your data. And after that, you save the model and register model. We'll go and see how the model gets registered. And that's it. That's only your training script. Nothing much fancy. So now comes the important job. This is like how to submit the job using a command script. Okay. So command script consists of few things. One is input, because you haven't still passed the input data, right? Because we told about compute environment. You can pass it in different ways. One such way is can directly give an access to the URI of your blob or your data asset. So right now I've given a complete URI of a blob. And then what is the test train ratio? This is the parameters which I'm going to give in. So if you take the parameters over here, data, it takes underscore data, and then it reads the CSV out of that. Simple. Okay. What is the train test? 80 to 25%. You can change it. You can run it different times. What is the name of that model name? Change it if you necessary. If you keep the same name, it will create versions. If you use different names, it will be a version one of different things. Exactly. So you can actually, I thought Azure has ML. Yeah, it is built on top of ML flow as well. So even if you want to do it, you can use ML flow. See, we are actually using ML flow here. It works very excellently with your Azure services. So if you put a log ML flow.log, it will get logged in your whole machine learning service, you can view it in your GUI as well. So yeah, you're correct actually. It has. And code command, I need to pass those input, test train, learning rate. The environment name is bootcamp-exp, remember? And I need to pass the version of it. If you create multiple versions, you can do that. Computers dev-cluster, we know we created it. And the display name. So I'll create another display name because I guess already I have created one. So I'm creating a command. Now I need to submit the job. It will take some time for you to run it, but you can see the details of that, how it runs and everything. So under the jobs, you can actually see it. We gave the name credit default prediction 1. So you could see the metrics and everything. Since we don't have time, I've already run one model. I'll just show you how it looks. Okay, it failed because of it because of the cluster. That's why your cluster was off right now. But yeah, this is how you actually run a training script. So once the training is done, your model will be uploaded to your model registry and you will be able to deploy that. In tomorrow's session, what we are going to do is we are going to take that model, deploy it, and run as well. Do we need to create the script in Python only or it will accept any language script? That's a good question. So command job can take up any scripts, but I think it works with Python. So it works with any script from my knowledge. So just it's like if you actually see it's Python main.py. So just run any script, it will work, and you're just passing command line arguments. So you can just run that it will generate any files. Can you show again how the model? So the model training takes some time. Uh, Instead of us sitting for 15 minutes, let's come back tomorrow again and we'll be able to see the model. And that's a next agenda for the next tomorrow's day. So we'll be able to see that model versions. We're going to pick the right model version and then, okay, how the model got registered through the code. Okay, I'll show the code aspect. Yeah, I can do that. So how you can register the model through ML flow. So in ML flow, just save the model and then you give the model names and arguments. That's it. Simple. Tomorrow will be a more hands-on session. Tomorrow we are going to see a lot of tools. So tomorrow we are going to see how you are going to deploy in production and how you can access the deployed inferences. And then we are going to see automated machine learning as well. That. So that gives a conclusion of today. Let's go back to our demo. And are you guys, we have 40 plus folks ready for quiz. Uh, yep. I'll give you a little bit of time for you to go and register, like start for your quiz as well. So just scan for the QR code or go to the link. Sorry. Go to the link. Okay. Either go conf.me/q327676 or just scan the QR code. That will take us to the quiz section. So yes, let's. Have you guys started registering? Just if you scan. So everyone who has, have you registered? So I'm going to Don't refresh. Please paste the link. Okay, let me do that. Sorry. Confirm.me slash Q327676. Scan the QR code or just go to the link. I'll quickly show you the. You don't have to see the screen. Your questions will appear on your mobile phone. If you're using from your mobile phone or your desktop, it will come from there. So you don't have to see any. I'm sharing my screen again that shows you. 30 plus people are already there. Let's give it till we reach 45 or 50. That's people who are watching here right now. Registration, you don't have to register actually. You can just join in as a guest. So how many folks? 38, 40, yes. So more than 40, how it's going to work, you're going to see a question on your screen. Don't look at the chat over here. Just stick to your what you see on your mobile phone or your desktop. Don't listen to my words or your questions which has appeared. Just stick to that. The question will appear with four options. Only one will be correct. After every single question, the leaderboard will be updated based on who all got the right answers and how fast they answer. So based on that, it will take up. So be fast and also be quick. So I guess I'm going to start the quiz right now. Check your mobile phone. Your first question is going to come. What type of ML problem requires both input and output pairs for training? Very simple to start with. Why few folks have skipped? Please just open your app. I don't think so. There is any way to just go back to our. Can you go back to QR? Just click on the link which I posted in the chat, Rahul. It's conf.me slash. Didn't able to choose. Okay, just don't. What I would suggest is don't come back to YouTube. Like you don't. If you're seeing from mobile, don't switch to YouTube and this and this. Just stick to the quiz from the this one. The next question on the screen. Yes. People who have skipped, are you feeling? Are you actually encountering the same? So second question done. 10 people got it right. MD Arvind is on the top of the leaderboard. Now comes the third question. What are different types of compute in Azure ML? Local compute, VM, Azure Managed Instance, Elastic Compute. Yeah, Elastic Compute is not a compute. It does not exist in Azure. So fourth question. Data assets are most useful when executing machine learning tasks as Azure ML jobs, ML experiment, ML compute, ML designer. It's most useful. Yes, it's useful for Azure ML jobs because it could be a input as well as an output for your jobs as well. In Azure, logical collection of resources is called pretty simple. I guess we talked a lot about that in chat as well. Yep, it's a resource group. It's not a resource cluster. Moving on to next question. What is the goal of reinforcement learning? To maximize reward, minimize penalty, to maximize penalty, minimize reward, to learn as many tasks as possible, to learn as few tasks as possible. Simple, to maximize the reward and minimize the penalty. Trial and error. Yep. Seventh question on the way. Which is not benefit of Azure ML command jobs? Configuring various parameters, automate and schedule jobs, gain better control over production environment, product and interactive development. It does not, your command jobs does not provide you interactive development. As you can notice that we just pass a script with parameters, right? It's not an interactive development, but it executes the script in the necessary cluster. You cannot see an interactive development in the cluster through your script. So eighth question. In Azure machine learning, what is a named process? Is usually the running of a script or a pipeline. What is a named process? Usually the running of a script or a pipeline. Workspace, compute, experiment, or an experiment run context. Yes, that's an experiment. Great. Named processes are experiment actually. Azure Machine Learning offers what as abstraction for cloud data sources? Azure data, data stores, data assets, compute data. Yes, it is data stores. It's very evidently we discussed the definition of it. Now coming to the last question of today's quiz. Adesh topping the leaderboard at 8 points. Keep it up. Alagappan is second and Ahmed is third and fourth is Arun Neelakandan. Let's see how it's going to change after the last question. Yes. Let's see who topped the leaderboard. Adesh got 9 out of 10. Congrats, Adesh is the winner of today's quiz, followed by Ahmed, Arun, Alagappan, and Harish for the first next 4 places. So we had total of 46 56 participants. Amazing response. So we will give the winners batch to the first top 5. So we have all your email. Like we'll reach out to you if we need any information. But do we have the email information? So Adesh, Ahmed, Arun, Neelakandan, Alagappan, Harish. If possible, reach out to me to LinkedIn. I'll just verify and let you know if I have your email addresses. If not, I need to collect it for dispatching batches. Rahul, unfortunately, you missed 3 questions at the top. Oh, I'm sorry that, but I guess you done pretty much well. So if we had 3 more chances, it might be good. Daily guys, you have been very noticing it. So seventh place, good job again. Vignesh, Karthik, and Prabhakaran. So that comes to the end of today. So coming back to the boot camp, so we have What else we have? We have our participation. Make sure everyone here today has signed up your participation form, filled it up, because after just 15 minutes after the bootcamp ends, I'm going to terminate the access for the Google form for the day one. So please do it ASAP. Congrats, Adish. And social media contest, we'll track you. We'll announce it at the end of tomorrow. So social media best knowledge sharer, or either tomorrow end or in the subsequent week. Quiz contest, we already have the winner for day one. We'll soon reach out. Okay, it might be network issues. We'll try to resolve that in day two, so you still have a chance if you're not able to do that in quiz today. And all the information about your Capstone and Microsoft Learn will be announced by end of tomorrow. So your bootcamp does not end tomorrow. It's going to be a start of your many machine learning projects and services and projects that's going to come in your life and your career. So that's what I feel, and I will strongly work for it. And before we conclude, I guess I told that I'll take up one general question. Probably we could conclude with that. If you have any more questions, just let me know in the chat. I'll do it. Okay, the question was, what is the right learning path for machine learning? So the best right path for machine learning is that you first take up the basics of machine learning, uh, work on that, then go with this MLOps and like whatever we do right now. So whatever we skipped on the demo one is that like extensively go and work on your core machine learning problems. Go to Kaggle. That should be your first good place. Go for any hackathons, and then come back to this bootcamp and finish off your productionizing or machine learning stuff. What type of certification are must have, good to have? Certification are debatable if you ask me, but if your job demands you to give a certification, uh, if you completely learn from this bootcamp, you are very well eligible to appear for DP100, which is your Azure Data Scientist Associate certification. Based on my view, your view of your current job market, which ML skills are most wanted? Um, which ML skills? I don't specifically see what skills that we need. Anyone who has an experience of not just a machine learning engineer, but a data scientist who can take up models to production, I guess they have the most valuable position in your machine learning team. So yeah, that's in my view. Can you talk about in-person meetups? Can you talk about so we mostly host our in-person meetups in Chennai, but we also trying to host that in different this one. Probably Navneet, if you are available, probably you could answer this question as well. If not, I'll just take it up the question. So if you have followed our uh, meetup, so I'll just paste our meetup link once again. Anyone who hasn't still signed up, please do it. That's where we post about the next upcoming in-person meetup, where it occurs and everything. You just have to RSVP and then appear for it. So I'll just paste the link to our.
Yes,
Yes, you
Vivek,
have
I
that
have
in chat.
pasted.
Okay, perfect. Thank you for that. Yes. So you could actually just join, and we have hosted several in-person meetups in past. So when we post a new meetup, you'll get an email as well. And if you are interested and you could spend some time, just RSVP. Only if you are able to come for the event, do RSVP, because we have limited seats and capacity. And you can come to the event, and we'll have much more interaction and in-person interactions over there. So what you can expect for day two? Your participation. We have all the announcements for your Capstone, Microsoft Learn, and everything. And also, we are going to learn different tools about your deployments as well as your automated machine learning. So, Navneet, probably you could give us the conclusion before we. Navneet, are you here? So, yeah.
Yeah, I have also pasted the WhatsApp group link. You can join there, and we will send you the notification on our events.
I will copy paste this link and update that in a GitHub profile also. Probably that's more easy. So I'll do that there as well. Yep. So thanks everyone for turning in and staying together for more than 2 hours. I hope you had wonderful session. So if you want any specific topics to be discussed as well, please let us know. We'll be able to arrange for that. Not just in machine learning, but anything around Azure as well. We'll be able to do it. And stay tuned for tomorrow. We have a lot of other contests and exciting learnings coming up. And do share your feedback in social media. Though it's good or bad, we like to take it up. And that's how we could improve ourselves to give you the best learning experience and sharing experience with you. And with that, I'm signing off today. And along with me is Navneethan. We are both of organizers of Azure Developer Community, Tamil Nadu. We have been running over 2 years, and I hope we see all those 60, 70 folks who are turned up today, tomorrow as well. And more folks, if you have more folks who are interested, tell them to turn up as well.
Thank you, Vivek. It was a wonderful session, and even we received a very good feedback in the feedback form as well. And thank you, audience. Thanks a lot for your patience on the weekend. Looking forward to connect with you all tomorrow as well. Thank you. Thank you, Vivek.
Thank you all. Yep.